What's going on, everyone? It has been a while, but it feels good to be back making content again. And we're going to be kicking off my first post in 2022 around a new Linux workstation. So my old laptop is about 7 years old now. So it was finally time to upgrade that thing. Zoom and Slack just couldn't hang any longer, as unfortunate as that is. So I have a new Dell XPS 15-inch that I'm going to be setting up as my next workstation. Now, I am going to be going through this thing end to end, from creating installation media to installing operating systems. I'll make sure to keep a table of contents, and I will also have all of these details in my blog. But if you're just looking for a quick and dirty tutorial that doesn't explain all the things, this probably isn't for you. It's going to be a long one setting this thing up end to end. So this is, again, a 15-inch Dell XPS. It is using an 11th gen Intel i7 processor. Now, at the time of this video, the 12th gen Intel processors are out. These include the P and E, or performance and efficiency cores. Really cool processing architecture, but unfortunately at this time, the Linux kernel isn't quite up to snuff with scheduling on that CPU. That's scheduled for 518, and I think at this point my Arch box is running 516 or 517. So I didn't really want to take the risk on the new processing architecture. It's also got 64 gigabytes of RAM, which I do spin up a lot of virtual machines using QEMU and KVM, but otherwise 64 gigs would be pretty much overkill. The hard drive is 2 terabytes, and the reason it's 2 terabytes is because I will be running Windows 11 and Arch Linux on this box. I want both to have about 1 terabyte of disk space. Arch is my primary OS for all of my work, all the things I do, but I do hop into Windows every now and then if I want to try things out or maybe run some software we're building on Windows and so on. It also has dedicated graphics. The RTX 3050 is inside of this thing. So I'll be able to switch between integrated Intel graphics when I want to save battery, and then dedicated graphics if I want to do rendering work or perhaps OBS to stream. And finally, it's using the FHD Plus display. It's 1920 by 1200 no-touch display. Now, this display is way less nice than the OLED that Dell has out there. And the reason I go with this display is it pulls a lot less power than that OLED. So I don't care about crazy resolutions in my laptop. 1920 by 1200 is fine. I'd much rather have the better battery life. So I did, in fact, go with that. And maybe the last thing we're saying on this laptop's hardware is this is a Dell, and I chose it because I'm used to the Dell XPS. I like the keyboard. I like the trackpad. It works pretty reliably. But being Dell, it's going to have things that aren't so great with Linux, like the BIOS and different things that we have to tune. If you're looking for a more Linux-ready laptop, you definitely should be looking at something like System 76. They make amazing machines, or I guess repurpose amazing machines that they then tweak to make more Linux compatible. But again, for me, I stick with XPS just because I know it, and it's kind of a continuation of a workstation I've already been using. Now we're going to start creating our installation media. So using 2 USB drives, we will put the Arch Linux install ISO and the Windows 11 install ISO on each of those USB drives. For Arch Linux, we can go to archlinux.org/download, find a mirror that we want to use. And inside of this mirror, we'll find the ISO file that they have hosted and grab the address. Then inside of a terminal, you'll notice I'm a sudo user right now. I can do wget and download this ISO. So essentially, I'll be creating these installation medias from a different Linux box and then putting it on the laptop in just a moment. While this is downloading, I've gone ahead and plugged in the USB stick that I'll be putting the Arch ISO on. So if I run an ls-blk or list block devices, I can see under dev SDD, I'll be able to cat the contents of that Arch ISO onto that drive. So to do that, we can just run cat, and we can say Arch ISO, put it onto dev SDD, hit enter, and then this will go ahead and begin the process of copying that ISO onto that USB drive. With Arch Linux on a drive, we can now get Windows 11 on a different drive. It's important from the Windows 11 site that we go for the Windows 11 disk image ISO. From here, we can choose the multi-edition ISO, click download. It'll then ask us for what language we would like that in. We can confirm that. And then it's going to provide us with a URL to download this. And we will grab the ISO from here. Now that it's downloaded, I've gone ahead and copied the ISO into this temporary directory. And the Windows install is a little bit different because we want to use a tool called Ventoy to actually create the bootable USB drive. One of the big perks of Ventoy is it allows us to tell the Windows 11 install to skip the system prereq checks. What's good about this is going to allow us to disable UEFI secure boot during installation. We want secure boot off so that we can install Arch Linux, and I'll show that in the BIOS settings a little bit later. To get Ventoy, it just depends on what distribution or system you're using. You can download it from their website, but in my case, I'm going to grab it from the AUR. So I can go to Ventoy bin and then grab the git URL. I'll go ahead and git clone that in this temp directory. And then once it gets cloned, I will grab Ventoy bin and run a make package si on it. And this will go through the actual installation of Ventoy on my system. And once Ventoy is fully installed, which it now is, we can see that a couple different Ventoy commands are available in the path. Now I've also gone ahead and installed a new installation medium or USB disk, and this is a 29.2 gig dev SDD. So what we'll do here is we'll run Ventoy GUI to get the drive initially set up. It'll ask me to authenticate, and with the authentication, I can choose dev SDD in here and then run install on Ventoy. All data will be lost on my disk, but then once this goes through, I'll have Ventoy set up on this USB drive. So this GUI just sets up the initial Ventoy system. What I'm going to go ahead and do next is actually make a directory inside of run media Josh, and I'm going to call this Ventoy mount. And what I'm going to do is then mount what Ventoy just set up. So under dev SDD1 in run media Josh Ventoy mount, I am going to mount this location. So we'll mount that together. And then using Ventoy, we're actually going to modify via one of its plugins the installation of Windows 11 to again skip those prereq checks. So we want to do Ventoy plug SON and then point this at our newly mounted device. So I'll do SDD, make sure I run as sudo, and this will actually spin up a web server we can go to configure the installation medium. I'll go to that web server and it will give me the Ventoy configuration portal. I'll go to global control plugin, and if we scroll down just a bit, you'll see an option for Ventoy Windows 11 bypass check set to not bypass by default. We want to choose one here, which is going to save the configuration to Ventoy that will skip a bunch of checks. One of those checks being secure boot, which is exactly what we want to skip so that we can install Linux and Windows. So that's it for Ventoy. We can then go back to our terminal, exit out, and if we just want to do a quick sanity check, we can look inside of run media Josh Ventoy mount, and we can see inside of here that Ventoy has put a configuration file in place. We also want to copy the ISO to this location. So I'm going to copy the Windows ISO from here, and we'll make sure I'm in the right directory. So I will copy the Windows ISO, and then grab that same location, run media Ventoy, paste it here, and make sure I'm running as the correct user. And then this will copy the ISO over, and now the Ventoy mount is completely set up as we need it to be to run this. So we can then finally do a sudo umount r against run media Josh Ventoy mount. This will unmount Ventoy. We can pop the USB stick out, and we're ready to start the installation in our system. Before going further, let's talk about the disk layout. The blue boxes are partitions set up by the Windows 11 install, which will happen first. The pink boxes are partitions by the Linux install, which will happen second. When we install Windows, it'll set up an EFI system partition that we'll be able to use. Additionally, it'll set up a required Windows recovery partition, and that'll leave us about 900 gigabytes for the Windows 11 root partition. This will be fully encrypted by a tool called Veracrypt. When we get to the Linux install, we'll set up a separate partition for boot, which will contain some bootloader details and also work with this EFI system partition. And then lastly, we'll have another 900 gigabytes set up for the root partition in Linux. This will be fully encrypted via a tool called dmcrypt. Now let's take a look at the BIOS to set it up for Windows and Linux installs. On Dell laptops, we can hit the power button and then the F12 key. This will bring us into the one-time boot setting menu. From here, we can easily access the BIOS setup menu. There are a few things we need to set up in BIOS. First off, we need to go into boot configuration and then find the setting for Secure Boot. Secure Boot is a UEFI feature that enables cryptographic guarantees that the binaries we are triggering on boot have not been tampered with since we got our machine. Now, this is especially complicated for our Linux ISOs and kernel because we would need to actually sign those with that same cryptographic keychain potentially. So while there are ways to do this, the best thing we can do here is just flip this off and hit yes to disable Secure Boot. And disabling Secure Boot is one of the primary reasons we needed to alter that Windows ISO for our install. The second thing that we need to change inside of BIOS is a specific setting around how the NVMe drive works. The easiest way in the Dell BIOS to get to this is to search, and through the search, we can type in SATA. And by searching SATA, we can see the NVMe operation. Now, on this XPS, it has RAID on by default, which provides some different functionality using this thing called an Intel Rapid Storage technology. It requires an extra driver when you're using it. Now, I don't particularly need or want these extra drivers, so I'm going to rely on AHCI NVMe mode. Now we can install Windows 11. We'll start off by plugging the USB drive into the machine, and by powering the machine back on, we can hold F12 again to get back to the one-time boot settings menu. From the boot settings, we can easily enter the USB drive. Once booted, we'll see the Ventoy screen, and then we'll just choose the Windows 11 installer, which will pop up and then boot into the Windows installation. From the Windows 11 installer, we'll just go through the normal motions, hitting next, going to install now. And the key thing we need to do here is set up a custom install so we have control over the partitions. From the partition menu, we can see a bunch of existing partitions set up by Dell. We're going to go ahead and delete every single one of these partitions. And with the partitions deleted, we can hit new and specify the size we want for the root partition. I'm going to go to 900 gigabytes in this root partition. When we apply, Windows is going to create the other partitions we've discussed, such as EFI and the recovery partition. With this in place, we've got some extra buffer for Linux, and we can hit next and install Windows. Once Windows finishes its install, it'll boot up and bring you through the normal mode of asking you questions. I won't bore you with all of these settings. They're just personal settings you're going to set up, but once complete, you'll have a bootable Windows machine. Once Windows is booted, we're ready to set up updates and all the default things we might need to do. The first thing I do is run to control panel, and I go to the power settings. There is an ability to turn off what Windows calls fast startup. We want to turn this off because it can do some weird stuff with the disks, especially in the dual boot scenario. So we'll flip that off. With fast startup off, we're ready to encrypt. We can head to vericrypt.fr, which is a page for the software I use to encrypt this disk. You can download it for free. There will be an exe, download it, install it, just like most software on your system. Once Vericrypt is available, we can launch the application, and we'll be ready to create an encrypted volume on this machine. We're going to encrypt the entire system disk here, and just do a normal type of encryption, encrypt the Windows system partition, and it'll ask us if we want to do single or multi-boot, and even though this will eventually be multi-boot, we'll start with single. We'll then go in and set up a password for the AES encryption algorithm that we chose, and we'll be able to start the encryption process. Now it'll collect random data. Just move your mouse around in this pool content to get it as randomized as possible. And it'll also ask you to set up a rescue disk. You might want to consider doing this, but I'm going to skip it. It'll go ahead and do a full encryption as well. I've skipped over kind of a pre-boot that it will do where it recycled my computer just to save time. But with this in place, now my machine is fully encrypted. If we go ahead and power down the machine and boot it back on, we should now see a new menu pop up. And this new menu is going to be a very minimal password box in the top left that'll ask us to type in our password. We can hit enter to the PIM number since we didn't set one. And this will decrypt the drive and let us log into Windows 11. And now we're ready to install Arch Linux. We'll plug the USB media in, just like we normally do, And similar to Windows 11, we will boot the machine on and hit F12 to get into the one-time boot setup menu. We'll choose the USB, and it'll give us a little grub bootloader that we can choose the first option on. This will boot us in UEFI mode, and Arch will take a little bit of time to get some of the initial hooks running and mounting of things, but eventually we will get booted into the installer. Now, I never do the actual Arch installation on the physical box. So what I start off by doing is getting connected to the internet using IWCTL. This will let us list our devices. My wireless card is listed as WLAN 0. I can then list the networks by doing station WLAN scan, and by then doing station WLAN and listing those stations out, I am able to see what's available inside of my network. Anteater is my network, so I will go ahead and do a station WLAN 0 connect to the Anteater network and put in my password. Now I should be connected to the network, so if I exit out at IWD and do an IPAS, I can see my IP is 192.168.3.124. I'll also ping google.com just to make sure I have outbound network connectivity. And I'm going to SSH into this machine. So with systemctl status SSHD, I can verify that the SSH daemon is running, and I can now SSH into this box. Before I SSH in, I need to set the password for the root user. So I'll just type password, put in 2 passwords, and we're good to go. Now from a new Linux box, one that has a GUI, I'm going to launch a terminal and then SSH in as root to that same IP address. Now I can fully complete the install from another machine with copy and paste functionality and a web browser. And now we're ready to set up the partitions. So if we do a list block devices, we can see the disks that are available, and I want to grab the NVMe 0N1 disk, not one of the partitions, but the disk itself. Once I run cgdisk, I'll have this nice interface for creating new partitions. We can see the free space at the very bottom for our Arch install. We're going to start off with that boot partition you might remember before we talked about the pink partition layouts. This boot partition is going to be at the first sector, which means right at the last partition. It will be 512 megabytes in size, and it will just be the standard Linux file system. We will set boot as the name, and now we have another chunk of free space at the bottom. This new free space will be our root partition that we talked about earlier. So we can go down to that free space, choose this first and size and sector to cover the full amount. So just enter, enter. Same thing, Linux file system, enter here for file type, and we're going to call this root. Now we have and can write our partition table to satisfy all the things we wanted for our Linux system partition. Now, as a quick aside, you'll notice that I do not put swap space in. This is a decision I've made because I do not want swap. Many laptop users do want swap because swap lets their machine hibernate where the RAM contents get written to disk. So that's something you might want to consider as you set this up. Now with everything written, we can quit cgdisk and do another list block devices, and you'll see the new partitions P5 and P6 are now available for us to start formatting. And now we're ready to encrypt P6, our root partition. So we'll copy the P6 name here, and we'll run crypt setup -y to interactively ask for the passphrase, use random to say dev random should produce the keys, and then put it under the LUKS format. We're going to specify that this should go against our dev NVMe partition 6. By hitting enter here, it's going to let us know that it will encrypt and ruin all the data. We'll hit yes in capital letters and then put in our passphrase twice. Once we've got our passphrase in, it's going to fully encrypt this partition, and we'll basically need to use a command to open up that partition going forward in a way that we can write and read from. So let's go ahead and open it up. We'll start off by running crypt setup LUKS open against that partition and call it crypt root. It'll ask for the password, we'll put that in, and this is us basically unlocking this partition. Now what this has done is put it inside of the kind of crypt root sub mapper directory, and we'll use that mapper directory in just a moment, but you can see crypt root sitting here underneath partition 6. So now we'll go ahead and make some file systems. We'll make the file system on ext4 with ext4 for dev NVMe partition 5. So this will be for our boot partition. We are just setting up the file system for that. And then we'll set up the file system for P6. Now, we can't just point it at P6 with MKFS because it is encrypted. So we need to do MKFS ext4 against dev mapper crypt root, which is the actual location where our data can be written and read from when it has been opened up in this way. With file systems in place in our partition, we're now ready to mount it and start doing installations. So we list block devices, we see P5, P6, and P1, which will be important for EFI. We'll start by mounting the dev mapper crypt root to the MNT. This will be the root directory. Then we'll create a directory in MNT called boot. Now, boot needs to be mounted to our partition 5, which is our boot partition. So we'll mount P5 against mount boot, and we'll make one more directory in mount boot called EFI. Now we know that partition 1 from Windows is the EFI partition. So we'll go ahead and mount partition 1 to MNT boot EFI. So essentially we have P6 set as root, P5 set as boot, and then P1 set as root boot EFI. We're almost ready to bootstrap Arch Linux, but first we're going to set the mirror list by editing etc pacmand/mirror list. Now the reflector has auto set the servers it thinks will work for us, but we're actually going to go to the mirror list on the archlinux.org website, choose HTTPS only mirrors, and find some known good mirrors that I happen to know work pretty fast for my region of the world. So I usually use MIT as the top one. We're going to copy and paste these mirrors into the file and make sure they're uncommented so that they get used. Setting this mirror list is important not only for your install, but this mirror list will be copied over and used for all package installs going forward. Now we're ready to bootstrap the system. We'll use a tool called Packstrap that is going to install packages to a new root directory. It's designed for new system installs. And then we're going to install these packages. Now, these packages are curated based on packages that I know I want out of the gate on my system. You'll notice that Linux is there in Linux firmware. There's also base devel and base, which provides some developer tools. Grub will be our bootloader. EFI Boot Manager supports that. And then I also bring in Vim to edit, Git to do source control, Intel Ucode to grab those drivers, and the Network Manager to give me an initial networking setup. Now, as these install, I will say that these are definitely just a very small subset of the packages I use every day, but this is my base system that I'll eventually use to install those other packages as a final step. Now we're ready to generate the file system table, and we'll use genfstab to do this. We can run genfstab for mount, put it at mount etc fstab. The -u flag sets it up so it uses UUIDs to identify the partitions. And if we look inside this file, this just makes sense of how dev mapper crypt root is our root partition, how dev partition 5 is our boot, and then how partition 1 is our EFI partition. Now we're ready to launch our new system. We can get into it by using arch to root and point it at mount. This moves us over, or moves our root over to mount. We'll then create a symbolic link from user share zone info, and we'll choose the region of the world we're in. I go with America in Denver because we have this silly thing called daylight savings time here. So this will map the time or time zone into etc local time, and then that will set my time zone settings. I'll then make sure to sync the hardware clock by doing hw clock --sys to HC. And now I'm all synced up from a time zone perspective. We now want to edit etc local.gen. This has a bunch of different encodings and languages that we want to set as our local or locale. We'll delete this comment on NUSUTF-8, save it up, and then we're going to go ahead and copy a similar setting by doing locale-gen, which will actually take those settings and set it up, configure our locales. And finally, we want to actually edit a file that is going to store the locale information specifically for our initial boot up, and then just some system settings that we can read as well. So what we'll do here is we'll just put lang equals and then that same locale setting we uncommented into a new file called etc locale.conf. With this, we're all set up from a language perspective and ready to start going. And now the most fun step, we can set our host name. We edit etc hostname and go in and just name our computer. So I'll name mine Taco, save it up, and the host name is good. Now we're going to set up the initial RAM disk, which is going to be available at etsy mkinitcpio.conf. We'll edit this file and then find the hooks section. Now, the reason we need to change this is because we're using an encrypted file system. So what we need to do here is add encrypt to this list of hooks. These are in an important order. And then we want to move keyboard before encrypt. So we'll put keyboard right after auto detect. Drop keyboard in, and now we've got our hook set up for the initram fs. Now, all we've got to do is run mkinit-cpio-p and type in Linux, and this will reconfigure or rebuild the initial RAM FS that our machine is going to use as it boots up. Now that we've got the initram F set up, we're ready to go in and set up our bootloader, grub. So we'll start off by getting a list of the IDs of our different partitions. We need to grab the ID for our encrypted partition 6. It'll be important for us to reference this in the grub configuration. We'll then edit etsy default grub, and you'll find a line in here that is grub command line Linux, and it should be empty. What I'll do is just paste in this UUID below it so I can store it for later. And I'm going to grab a little snippet of text here that I put in, and I'll explain it here in a moment. The snippet of text is basically going to give different instructions to grub. It's going to first identify that this UUID, which we're going to copy from below, since this is an old UUID, we're going to put this new one in here. This UUID is a encrypted device. We are then going to specify that the crypt root it should open up should be at dev mapper crypt root, which is where we have been setting it, and it is consistent with our fstab record or file system table record. So this will give grub what it needs to do to set up that encrypted partition. By default, grub will have a record for Linux, but we also need a record for Windows. So we can edit etsy grubd and go into 40_custom. This is where we can put a custom configuration in that will be generated and included in the grub config. Now, I have a big chunk of text in my blog that I'm going to be using here. The blog is in the description of this video if you want to grab the same. But if you're setting up a Windows partition like me, what I do is I copy the content of this grub menu item for what used to be Windows 10 in this picture, but is now Windows 11. And I paste that into this extra config file. Now that this is pasted in, there are a couple things that I need to change here. Actually, the menu entry says Windows 10, and I actually should have set this to Windows 11, but that's just a cosmetic item for now. If we look in here, we now need to set the UUID for the partition 1 or the EFI's partition. So this is a key thing to check for. A bunch of ways that we can do this, but what I'll do is just save this file, go back to BLKID, and then grab the UUID for P1 or partition 1 that represents our EFI partition. So I'll grab that onto my clipboard, and then I will edit this file again and update FS UUID with that partition 1 UUID. You'll notice the chain loader is not pointed towards Windows, but it is pointed towards Veracrypt, because we want to call and boot Veracrypt to unencrypt Windows so that then Veracrypt can launch Windows itself in an unencrypted fashion. So we'll save this up again, and now grub is pretty good. With grub set up, it's now just a matter of generating this grub configuration file. So there's a couple steps to this that we're going to do. The first step we're going to do is we're going to run a grub install to set up grub on the system. Now that grub has been installed, we can do a grub make config, and we want to push it against boot grub grub.cfg. This is the main config file. Now, what this did, if we edit and look inside of this file, is it took those menu entries and configurations and made this massive file that contains all of the pieces. Again, it should say Windows 11 there. Now we can just save up this grub menu or really just quit because it did save it, and we're good to go with grub. Finally, we can set up our user. So we'll set up password for root again. This is on our, again, Arch system. So we have to do this again. We'll do a password for root. Then we want to create a user. So we'll user add under the group wheel, in my case, naming it Josh. And then we want to set the password for Josh. So similarly, we'll do password with Josh and then put in the password for the user. Now I want the user Josh to be able to run sudo commands when prompted. So we're going to run vi sudo, which will open up the sudoers file. We'll then go down and find where wheel is specified. And the setting I like to uncomment here is to allow members of wheel to execute any command. This will prompt them for the root password, which is what I want if I'm running a root-based command. Now let's also set up networking. So we'll use systemctl enable network manager to enable the network manager unit, which basically turns on networking by default. This will let me connect to wireless networks without any additional packages. And we pretty much have a base system ready to go. So we'll exit out of our chroot. We will unmount from the mount directory our partitions, and we are ready to reboot the system and validate that we can boot into Windows and Linux. Once the machine reboots, we'll see the grub menu here. Really tiny in the far left, you'll see Windows 10, which again should say 11. And then we'll put in our password for Vericrypt. Password goes in, the PIM remains blank, we'll hit enter. And now, if we unencrypt successfully, we should boot right into Windows 11. Now that Windows 11 is back up, we can log in and we're good to go. Now let's see if we can boot into the Arch install. Similar to Windows, we'll see the grub menu pop up and we can choose Arch Linux. Once it boots up, it'll ask us for the password of our encrypted partition P6. We'll put that password in, and then we'll be asked to put in our username and password. So we'll enter those, and now we're in the Linux system. Granted, it needs packages for a GUI, but what we can do first is go into nmty connect as a sudo user, and we can put in the password for the network we want to connect to. This will get us initial wireless connection so that we can go in, install packages, and ideally get to a user interface. I'll just double check to make sure I now am able to access the outbound internet, and I'll set up a D directory where I'm going to clone a repo. So I have a repo I maintain at github.com/octets, and this repo is Linux-desktop. This contains a list and automation for installing all the base packages I use when I set up a Linux desktop. You'll see my make file here, and most importantly, make install-packages is key. That's where I maintain a list of all the packages I use every day, and it will set it up and install all of these packages for me on my system. Now, I won't have you watch every single package install from these make install packages, but I do have a blog post and video on how I set up the desktop environment with these scripts. Once it's done all the installs for all the packages I'm expecting, I then just go ahead and run make install term, which compiles and sets up simple terminal on my machine. You can use any terminal, of course. And I do make configure, and that brings over some of my dot files and some different configuration, like I make the grub menu a bigger font and small little tweaks here and there. But the key thing is all my packages and configure in place. And now if I look inside of the file .xinitrc, we can see some config here. Most importantly at the bottom, that start xfc4 is there. So if we run startx, boom, we're in a Linux desktop environment. Now I'm just gonna skip ahead after a couple minutes of configuration and show you the end state. So now we're in the desktop environment. I have my keys mapped, D menu is set up to give me a list of apps. I can launch my terminal with my key bindings, web browser with my key bindings, move windows around and rearrange them. I am good to go. So I left the desktop environment setup out again because I do have a blog post on it, but I hope you found this post and video really interesting. A full setup end-to-end of a laptop using Linux and Windows. If you liked it, feel free to subscribe, let me know in the comments, and I'll see you next time.